Natural logarithms. The definition of the natural log is that if n is the natural log of m, written n equals the natural log of m, if and only if m equals e to the power of n. Natural logs, the big idea. Our textbook defines natural logs as a natural log is when a number is written as a power of the irrational number e. The exponent in the expression is the natural log of a number. But what does this mean? Any positive number except for 1 can be the base of a log. The number e is used as a base for the natural log function when used for real-world application. Any log that has e as its base is considered a natural log. Then you can solve the equation like a base 10 log, where e is approximately 2.7. Logs, everything that you must know. The log function is y equals log base a times x, where a is greater than 1. Similar to an exponential growth or decay graph, log function graphs never touch the y-axis, no matter how close they get. The function y equals log base a times x can be rewritten as a to the power of y equals x. But natural logs use the letter e, which is similar to pi because it is irrational. E is approximately equal to 2.7. The domain of a natural log is all real numbers, and natural logs are often seen as a part of an equation. How to solve natural logarithm functions. Part 1. The basics. Previously, we learned how to solve log base 10 functions. We know that if we see a log problem that says log base 10 times 1000 equals x, that can be rewritten as 10 to the power of x equals 1000. This makes it a lot easier to figure out because we know that 10 cubed equals 1000. However, with natural logs, you don't have 10 as your base, but instead you use e. We use e when we want the exponential growth or decay to be continuous. When writing your equation, we don't use log base e x, but instead write the natural log of x, or ln x. Your calculator does have a button that makes this part kind of easy, but if you don't have a calculator to use on that part of the test, or just don't have one in general, you know that e equals approximately 2.7. So we have some natural log applications. Natural logs are frequently found as a part of a formula. For example, the book uses the formula d equals negative k times the natural log of I over 10. So the situation here is that according to the Beer-Lambert law, if you shine a 10 lumen light into a lake, the light intensity, represented by I in lumens, at a depth of d feet underwater is given by d equals negative k times the natural log of I over 10, where k is a measure of the light absorbance of the water. For a lake where k equals 34, at what depth is the light intensity of 6 lumens? So we can use our application of the natural log and solving for a natural log after we sub in our known values to find the answer to this problem, or problems like it. The natural log also has something called the inverse of natural logs. The inverse of natural logs is represented as y equals the natural log times x. The relationship between the two equations can be understood in that the inverse of a natural log is the reflection over the y equals x line. So the easiest way to remember everything that you just learned about natural logs is to put it to something that kind of compresses all this information and will help jog your memory when you need it. And I like to do that by doing a little poem that rhymes, so it sticks in your brain easily. And this is how it goes. Natural log uses e. I know that easily. E is about 2.7, and knowing this makes math like heaven. When solving becomes hard to do, I put the function in exponential and shout woohoo! Thank you so much. I hope that this helped, and happy studying.